everyone, and welcome to this session, The Journey to Net Zero, Closing the Gap on Grids, brought to you by the International Chamber of Commerce and ABB. I'm Joel McCower, Chairman and co-founder of GreenBiz Group in Oakland, California. Delighted to welcome all of you, both here in the Blue Zone at COP28 in Dubai, as well as to all of those watching online. A great panel, which I'll introduce in a moment. So here's the assignment. Create and support electricity grids that are adaptive, resilient, reliable, smart, bidirectional, and affordable, and that provide power to all who need it, everywhere, all the time. And that does this using carbon-free energy sources profitably, or at least break even by generators, operators, and utilities. That's the moment and the opportunity that's before us here as we sit here today at COP28. And according to a new IEA report, that means, this is a quote, adding or refurbishing a total of over 80 million kilometers, that's about 50 million miles, of grids by 2040, the equivalent of the entire existing global grid. So how do we do that? Can we do that? What are the enables and barriers? Who needs to be at the table? What kind of investments are made? And who should be paying for all of that? We're going to answer and solve all of these questions exactly in the next 60 minutes. So joining me here are Melanie Nakagawa, the Chief Sustainability Officer at Microsoft, Morten Virad, the President of Electrification at ABB, and Christiane Ruby, the Secretary General of Eurelectric. Joining us a little bit, caught in the traffic of COP, is Beatrice Buffon, the Group Senior Executive Vice President, International Division at Électricité de France. So, Morten, let's start with you. As we talked about, this grid of tomorrow, it's going to be smart, reliable, bidirectional, clean, and all of these things comprised of distributed energy resources and storage and everything else. Where are we in this moment? Just that's a level set that what is the big opportunity right now, and where are we in terms of what's needed to get from where we are to where we need to go?
Oh, thanks, Joel. We are at, first of all, the whole world is going electric. I think we all recognize that when it comes to the use of all about electric cars is a very practical example where you see it, but maybe not what we're aware of is that everything is turning into electric drivetrain or electric motion, but also electric heating, electric cooling. So this is a big shift that is happening all over the world. So at the same time we need to decarbonize, and that means again we need to electrify. Because electrification is normally the answer to how we decarbonize all over operations, buildings, and transportation. So that's kind of the backdrop of it. And at the same time, we said that now, and I'm happy to see here at COP, we already got 118 countries signing up for the tripling of renewable energy for the next up to 2030. And also doubling the initiative on and the actions on energy efficiency. So that's kind of the positive backdrop, but it also with that leads to a huge challenge on the electric grid, because according also to the International Energy Agency, that the report they sent out 3 weeks ago, you also see that we need to the electricity consumption the energy increase will be 10x any other energy sources for the next 10 years. So that is the challenge for the power grid, getting enough power to do that. Electric charging, I mean, just a standalone, it's a 10 terawatt hours that is needed, which is again 10 times more in 2030 than what it was last year. So everything will rely way more on electricity, and therefore we need to upgrade the grid and making it more resilient towards these changes, because at the same time we see the increased capacity or the need, we see also the more extreme weather around the world that is challenging also the stability of the grid. That's why, like in the United States, you will see, I think it's 64,000 miles of cables or our headlines that is now being put underground with underground switchgear and underground cables. So this is a massive investment in the grid that will happen in the next 10 years. It's not like we often talk about 2050 commitment, but this is more of 2030. It needs to happen in today and next year and the coming years. So the investments need to happen, and it is. And many of the utilities that I meet with around here also have much higher capex budget now, and I'm sure we will hear more from Christian on that as well. So that is happening, but we need a much smarter grid, and there is where companies like ABB, but also together with Microsoft making more and other partners in the industry, making the grids more digital and more resilient, so stronger, but also smarter. So that's the whole challenge we have in front of us. And I'm very excited to be in that industry and being able to provide some of the solutions, not all, but many of those solutions that will happen for the future.
Well, it's obviously a huge opportunity space, but when you look at that opportunity space and that you look at the grid operators, whether they're nations, national governments, or privately owned or publicly owned consumer cooperatives, how ready are the grid operators to lean into this moment and seize these opportunities?
I think it's not a single global answer to that, because I see very, let's say, progressive utilities in some parts of the world, especially, and I would mention one of my home countries, which is Norway. I know that utilities are very advanced in digitalizing the network down to a much lower level than what I see in other parts of the world. But we have to remember that on a global, a lot of where we will see the energy consumption going up in the future is in places where it's not electricity available today, in that we're talking about many of Asian countries, but also African countries. So I think it's so important that we don't go through the same energy transition in many of the development countries, but we go straight into the right solution, which is going straight into renewables, and don't take the path through fossil fuel-based power generation. So that's a challenge, I think, for all of us as well, to get that and to help developing countries going into the right starting point right away, and as they don't take that detour versus carbon-based power generation, which is where we have more in the, let's say, the developed part of the world will have to more developed part, then you would have to make that transitioning happening now and replacing a lot of that fossil-based power generation that we still rely on.
Yeah. Melanie Nakagawa, Morten already invoked Microsoft's name. I'm guessing that most people don't think about electric grids when they think about Microsoft. Talk a little bit about, first of all, where Microsoft fits into all this.
Great. Well, thank you so much for having me, and hello to everyone else out there. So I think that's it's a really interesting point you make, because it's something that is actually a key priority for Microsoft. I mean, here we are at COP28, and I'd say these discussions around how fast we decarbonize the grid is one of the key issues that we're engaging with, discussing with others, having focused discussions on. And the reason why is a few reasons. One, Microsoft in 2020 set an ambitious goal to be carbon negative by 2030, as well as a few others, including water positive, zero waste, and protect ecosystems, all by 2030. When we think about that carbon negative goal by 2030, it first and foremost includes all scopes. So we want to hold scopes 1 and 2 to near zero, and then dramatically reduce scope 3. When I say that, again, electricity and energy grids are at the heart of all of those. For scope 1 and 2, which are direct impact, that's really clear why energy matters. It matters to the over 60 regions in which we operate with our data centers that consume energy. But in scope 3, which is 96% of Microsoft's carbon footprint, is in our scope 3. That's the value chains or supply chain. And when you break that down, it breaks down to things like semiconductor chips that go into those data centers and our hardware. It comes into things like building materials like cement and steel that are large energy users as well, and electricity consumption of our downstream users of our products. So again, when you think about that, energy is core and electricity is core to all of that. So if we're gonna be successful in reaching our goals, we need those grids to decarbonize fast in all the key markets around the world. We are a global business after all. So to that end, we've been doing things like supporting the tripling of renewable energy by 2030. We joined several other corporate leaders on urging for that action, and really pleased to see, I guess on day 2 of this conference, those countries coming together and announcing that commitment. It also includes things like working with ABB and other companies to really move forward with technology and solutions to accelerate transmission, accelerate clean energy deployment, and it's really important that we do that. The last thing I would say is, in addition to our carbon negative goal, we really wanted to kind of break that up to mean, what are the components to that? And one of the key components was to set a goal it's called 100-100-0. That means 100% of the electrons, 100% of the time are coming from carbon-free sources of power to our data centers and our facilities. And so to hit 100-100-0, again, part of that requires a fast decarbonization of these grids around the world.
And where are you on that journey?
So we're making progress across all of these. I'm happy to say that to date, we have contracted over 19 gigawatts of renewable power to date, and that makes us one of the largest corporate purchasers of renewable power to date. And for those that are, experts in this space, far more than myself, I'm sure, it's really exciting to see the role that technology companies have played in accelerating the growth of renewable power. Like I said, there's probably a handful of companies, that, especially from the tech sector, that are the largest purchasers of corporate purchasers of renewable power. And I think that's a really good example of where corporations can play in standing up and advancing markets and creating markets where there haven't been markets to date.
Christian, first of all, I'm not sure how much people know, at least outside of Europe, that you're electric. So I'd love to hear a little bit about that. But also talk a little bit about the grid security and some of the needs there and I know I also want to come back to you, Melanie, on this because you had a national security role and you've looked at climate and security, and I'm sure you have things to say about this. But Christian, talk a little bit about how much security plays a role as you look at the grid in Europe, but also, again, talk a little bit about Eurelectric.
Thank you, Jill. So Eurelectric is the trade association of the European electricity industry, meaning that we represent some 3,500 companies across Europe that deal either with production of electricity or transport of electricity. And we also deal with the likes of Microsoft, Google's, and ABBs in our membership, the supply chain and different types of service providers, customers. So coming to the security component, so this energy transition that Morten outlined, which is a fantastic feat and a fantastic journey for the sector, but also, frankly, quite challenging, is changing these years in the sense that on top of doing this quite technically complex transformation of the entire sector, the production, reinforcing the grids, and so on and so forth. We're now seeing this unfold. We have to do this on a much more complex backdrop with geopolitical tensions, ideological rivalry, and all what that entails in terms of new threats, be it physical or cyber threats, fragmentation of our supply chains, and so on and so forth. Specifically coming to the security component, I would focus on two distinct areas. Morten mentioned the issue that we're facing much more extreme weather, and for grid operators, this is really a major issue across Europe, but I should say across the world. So specifically, the extreme weather means that we need to build grids more resiliently. We need to invest in more physical assets, and we also need to reinforce them with digital solutions. We broke that down a few years ago in a study and came to the conclusion that over the 2020s, we're looking at a ballpark figure of 8% of all investments that are directly related to the resilience and the, let's say, the climate impacts on the grid.
So what does that translate to in euros?
So the aggregate amount of investments, and this is, let's say, 2 generations of targets ago, so we can easily add something to this. The ballpark figure for the 2020s was some 400 billion euros to be invested only in the medium and low voltage grids. So if we say 10% of that, we're talking some 40 billion euros that go alone for this price tag. And it's about more robust cables, lines. It's about cooling of transformers, of substations, and so on and so forth. And it's about flood protection and so on and so forth. So that's one, let's say, very serious threat and security aspect of the grid. The other one stems from the changed, let's say, geopolitical situation where we're seeing an increase of cyber attacks against the grids and also now now, on a couple of instances, real, let's say, physical attacks on infrastructure. I mean, look at Ukraine, that's one big attack and at the electricity infrastructure, but also in the EU, we've seen, unfortunately now, attacks against energy infrastructure. So the situation is quite different, and I would say, especially on the digital side, this is a very delicate conundrum, because a lot of the journey on, let's say, realizing the potential of the digital technology is about opening up the data layers and providing access to people to provide new types of services, aggregate data in different ways. So that's the opportunity. The threat here is that if you open up the data layer, you're gonna also potentially open it up for let's say, malicious actors. So we need to strike a very careful balance and find out how we, let's say, achieve the climate objectives while staying secure and avoiding malicious attacks on the grids.
Wow, I think you summed up the challenges pretty well, that not just in Europe, but I think everywhere. Well, let's welcome Béatrice Buffon from Electricité de France, EDF, to the conversation. And you're, of course, one of the, I assume, a member of Christian's group. How do you view the challenges? Are there some specific challenges? Also, is your service area restricted to France, or is it beyond? Forgive me for not knowing this. And in your service area, whatever it is, are there some particular challenges that you're seeing right now?
Yes, hello. Sorry for the slight delay. Yes, so EDF is an integrated utility, and we are investing heavily in the low generation side, but also in the networks indeed, and also in the electrification of uses. So upstream to downstream, and for us it's key, because to succeed with energy transition, we need to optimize the whole system at the same time. And for networks, it takes time. It takes too much time probably, but you need to have lots of consultation. Permitting process is cumbersome, and we need to plan for it. So we're going to invest, for example, 5 billion euros per year in the distribution in the coming 10 years. Why? Because we need to modernize, we need to digitalize, we need to extend the grid to inject more renewable capacities, because small renewable projects are spread throughout the territory. It's a new challenge, and we need to develop the network to be able to take all the renewable energy produced. We also have deployed 36 million smart meters that enable us to collect data and to have remote monitoring. We have done that with smart meters, but we need to do it with the global network. We need to put more sensors. We need to implement digital systems that will allow us to ensure the safety, the security of the system at any moment, regarding, for example, frequency variations, and it will allow us to optimize the use of the system. When you have a better knowledge, a better understanding of the electrical flows in your cables, you can optimize the use. You can maybe transport more electricity sometimes, depending on the climatic conditions. But to do that, you need to have really a deeper understanding and live monitoring of your system. So that requires billions of investment, and that's what we're going to do in France. Regarding transmission, we also need to increase and reinforce and digitalize our transmission system. And just one example, even if we are not bad at planning in France, we were a bit slow, however, as in other countries. And considering the deployment of offshore wind farms, we wanted to accelerate offshore, and we're going to accelerate offshore, except that we have been working a lot on the permitting processes for wind farms. So great, we have been able to go from 10 years to 7 years, which is still too long. The issue is the network is not ready. Because when you put lots of power offshore, you need to have transmission systems adapted. And in fact, it takes more time. So lessons learned, now we anticipate, and the transmission operator in France, RTE, is deploying in advance substations and offshore cables to be ready to inject electrons offshore. So it is a big challenge. Of course, it depends on each country context. And we are present on the international stage, also in the transmission system. And we see very different cases. We are, for example, in Chile, where solar production is in the north. You have consumption in the middle or more south, and they have lots of curtailment. And it's long to deploy, kilometers of cables, and you have many communities and long consultation processes. So they have looked into new systems with large batteries, and they intend to deploy 500 megawatt batteries near the production, another near the consumption, so that network can adapt to intermittent production and to new needs in terms of consumption. So that big challenges, which is the same in Germany with offshore wind in the north, consumption in the south. So in France, it's a bit different because we have already production in several places, so it's not north-south, but still, it is a challenge. It is a challenge in terms of financing, in terms of planning, in terms of schedule, so that everything comes together at the same time. And interestingly, I will finish by that, RTE has issued a report about 2050 scenarios. And the strategy director of RTE told me, they can see who is looking at the document on the web. And the part that had been less looked at is the part on the network. Because I think people do not realize yet, in France at least, that it is a key part. And they are looking at the production side, but not so much at networks. They are not aware of the challenge there yet. But it's coming, obviously.
Wow, the complexity of this is non-trivial. Go ahead,
Maybe
Martin.
just a comment to it. I think we have a great challenge here in how to deal with the transmission, but therefore also so important to also do more of distributed power. So the rooftop PV installation everywhere is also what helps reduce the need, or at least some of the need for transmission, because this will or else be a big bottleneck in the utility grid. So I think that, and even we talk about energy efficiency that we need to drive more of, because again, that reduces the need for power generation and expansion, and it reduces some of this, the stress that we'll have to put on the network when we are having quite a big difference between where power is generated and where it's consumed. And this is the same really in every country. So in average, we have enough power, over the year. The problem is that it's not used at the right time, and it's not used at the right place. So if you would be able, but it's a bit like traffic. You have enough roads in the world, so it should never be any queue. But we could be stuck there for hours at a certain time of the day.
Well, you opened the door to something I was going to bring up later, which is the decentralization of the grid, and how much do we really need a grid, or do we, as we build in for this new era of electrification of everything, how much of this can be at the microgrid, even nanogrid level, or how much we really need to rely on the traditional model we've had for the past 100 years of a big centralized grid. So Morten, talk a little bit about what you see, and I'd love to hear from others as well. In terms of,
and we really need everything, which is, and we need to do it now. We need to upgrade the transmission line, because we cannot do everything on microgrids locally, but you have to do that as well. You have to use as much we can do locally, where you put supply and demand next to each other. That's it.
And talk about what are the limitations of that, why we still need the central grid.
You need the strength of the grid, because all the renewable energy we put in now, like with PV or solar and also wind, you don't have the resilience or the stiffness of the grid and the grid connections. That's where the large power plants that we have, these are what keeps the network strong. And that is what we're missing when we're putting in so much in the renewable energy. So then you need to talk about, you can do this with grid strength, either with with synchronous condensers, which gives that mechanical strength in a net, or you could do it with power electronics, like battery system. And I think, again, here we have to do everything. It's not like, there is not, unfortunately, one silver bullet just to fix it. So we have to have a long list of actions that we have to take in the utility space or the power space to be able to deal with the future and this huge increase we will see in the electricity consumption of the future. So it's all about strengthening the transmission, but it's also about strengthening the local power generation, I say local to supply and demand, and it's also to drive energy efficiency. So because that will also reduce a bit the stress. And then it's the last point is, which is more of load management. That's what we also talked about here. It's like in our houses or our homes where you want to use power when it's the cheapest. So you charge your electric car during the night instead of during the hours where everybody are making dinner and the consumption is peaking. So these are the, again, do load balancing in your homes, but that we can then have to do the same thinking on the distribution side or even on the transmission side. So this is all load balancing and load shedding to make a more stable grid.
Melanie, talk about central versus decentralized grid from the perspective of a Microsoft data center.
This is a great point. I mean, one thing to add to this conversation is you're seeing digital technologies be a key part of this enablement. So there is this aspect of you need everything everywhere all at once, because I think it's just a very good title for a film, but now it's a widely used phrase.
It can apply to almost anything.
It can apply to everything now, which is really kudos to that film. But to that point, though, for Microsoft, we're seeing really interesting uses of technology innovation to get at some of these concerns. So take decongestion of the existing transmission. So yes, we need to increase transmission and build new, but as Beatrice mentions, it can take a long time to do that. So what do you do with the existing grid? Because as Morten pointed out, we have some of the power there. It's just not getting at the right time. So Microsoft invested in a company called Line Vision, and Line Vision is using AI-enabled systems to actually help decongest existing grids. And the good news is it's already been applied. And upon its early application in National Grid UK, it has shown a 60% additional capacity being brought online, which is around 600 megawatts of offshore wind, which, as Beatrice mentioned, is you want to move more offshore wind online. Here's one way to do it on existing grid. So that, I think, is a great example of innovations today being deployed that are dealing with existing transmission to help bring more online, which is really important for us to hit our 100-100-0 commitment, because we need more carbon-free sources of power coming onto the grid at any given time. Now, when you think about this idea of what comes after that, the next piece is how do communities benefit as well? So to your idea of decentralization, central grid, we want to make sure that as more power comes online, it's not just serving Microsoft's purposes, but also the communities in which we're involved with. And that really involves really innovative new ways of dealing with energy contracting. How do you build in community benefits into those contracts? We work with companies like Volt Utility Systems and Sol Systems to actually look at how do you provide a funds through those contracts to provide community benefits to historically marginalized communities when we're going out to increase capacity, not just for Microsoft, but also the community and surrounding area around it. And these are the kind of partnerships and the new era of where we need to go and where we are going as sort of utility providers, as technology providers, as energy consumers, that actually get at this issue of let's bring more carbon-free sources of power online, let's get the transmission to move those, and let's ensure that the communities around us benefit. The other piece I would just mention is, you mentioned on the solar and wind piece, battery storage, and that's another key innovation we need to see accelerated. And this is another great use and an opportunity of Microsoft's Climate Innovation Fund that invested in Form Energy, which is a long-duration battery storage. And there's just examples of where corporate actors can play in investing in innovation and helping to catalyze innovation that is not only helpful further upstream in our system, but also for other players downstream in the market.
I also imagine that as you set up data centers around the world, and as you do site selection, that these all, first of all, finding the sites that are ready for Microsoft, not just in terms of the grid, but in terms of all of the other social and environmental pieces and community engagement and all of those things. How easy is that these days, or are you finding that there's just not enough selections, or is everybody potentially a site these days?
Well, it starts with engaging with the governments and understanding where government commitments are, where government demand is as well, and how do we help advance government commitments towards their own targets. So, being here at COP28 is a great example, because you have country leaders saying that they want to be putting in place commitments towards the Paris Agreement goals that included these nationally determined contributions, but it also included the sobering truth that we're not on track. And the global stocktake says that all of the countries are not necessarily on track or not on track. And so if that's the case, where do companies like Microsoft play? We start with, how do we help countries get on track by, in the site selection conversation, saying, well, we will be an off-taker of carbon-free sources of power. You had these commitments on the table. How do those two, where does that overlap? How does our demand for more carbon-free power, how does that incentivize, accelerate a country's progress to their nationally determined contribution or their climate goal? In the case of the EU, the most recent grid action plan out of the EU talked about how much more, I think it's 60% more energy is going to be needed by 2030, I think was the stat. And if that's the case, again, how does Microsoft participating in those markets help support that growth, but coming from carbon-free sources of power?
Yeah. Well, it's no longer just the price per kilowatt hour. And I'm sure some of the places you go, you find infrastructure gaps. And I'd love to hear from both Christian and Beatrice in terms of what are the infrastructure gaps you're seeing now in Europe and in your general overall service areas globally. What are the big gaps that you see? And I'm sure it depends on the localities. I know that's a very broad question, but is there a way to sort of sum up? And is it on the transmission and distribution side? Is it on the transformers? Where are those gaps?
So we quantified sort of the investment need a few years ago, as I mentioned previously, where we went and had a deep look at especially the distribution grids of Europe. Because one thing we've seen is at EU level, there's been a very clear sort of vision that interconnectors are needed to build a European market. What we hadn't seen for a long time, now it's beginning, was the realization of this decentralization of the system and the corresponding planning and the investment in the low voltage grids. So if we look at the EU today, we have some 40% of the grids that are around 40 years old, which means that this is a 20th century infrastructure that we now need to use to power the 21st century with a much more digitalized economy, a much more electrified economy, and that's why we essentially need these investments. So we're currently in the process of re-quantifying, because we have now 2 new generations of targets since 2021 when this study came out. But at that time, we came to the conclusion that we need some 40 billion euros of investments in the distribution grids annually up until 2030. And from there, we need to increase further. So that's a little bit the picture on let's say the aggregate investment needs. When we look at what needs to be built very concretely, we broke that down into what are the needs coming at the grid. There's renewable integration, there's electrification of transport, there's new types of demand coming from data centers and so on and so forth. There's the digitalization piece, there's the sheer modernization of the grid, replacing poles and so on and so forth, and there's the resilience piece. So these are the sort of key drivers of investment needs that we see. And if we look at companies today, probably Beatrice can talk more to that, we see shortages across the supply chain, whether it's transformers or cables, lines, we're short of pretty much everything. And that has to do with the fact that there were on the one hand, in need of a radical upscaling of the industrial capacity. On the other hand, we've also experienced a very quickly changing macroeconomic environment, which means that all of a sudden, with increasing inflation rates, increasing WACC, it's getting more difficult for companies to justify investments, to make that final signature, and also for supply chain players to build big factories because they need to be reassured that they see the return on investment. So we are in a bit of a shortage situation across this space, I would say.
So that's interesting that the pinch point, if you will, is not necessarily money, it's not necessarily the desire, it's the equipment itself that you need to upgrade the grid is just not there. That's
well, I would say more and more it's both. If we talked 3-4 years ago, everybody would say the world is awash with money, and yes, it is. But the investment case is getting more difficult because interest rates are going up, and all of a sudden the business case is changing quite significantly. So today perhaps not money, but it's the business case and the physical equipment.
Yeah. How is this affecting EDF?
Well, first, I would like to say that I fully agree with what you said, that we need everything at the same time. Centralized solutions, decentralized solutions, that we cannot, think that one solution is better than another one. I think we need all low carbon solutions. Transmission, distribution, distributed solutions are really good. Energy efficiency measures. But I'm just puzzled sometimes because I heard some debates here where people are still, thinking, maybe we should do energy efficiency and not so much production or whatever. When you look at scenarios, you need to do everything. And even by doing everything, we are not there. So I was really pleased to hear what you said. Yes, on the transmission side, we are facing a shortage. And the consequence is that projects take longer. We need to secure industrial slots quite early in the process. So it has a cost. It is risky because you need to pay upfront big amounts to be able to secure the delivery of your project. So it's something we need to work on because it's not going to improve. We said that we have to invest more in transmission and distribution. So we need to work on the supply chain. I was thinking that it's maybe a good time for ABB and other competitors, too few competitors, because it's a seller market for sure. But even for them, it's not a good situation because they are full booked over too many years and it's becoming too tricky to manage. So the consequence is that it becomes bottlenecks and that it slows down gigawatts of renewable projects. So it has a big consequence on our CO2 emissions and on the implementation of energy transition. So that's a big part. But the other big part is what we said is planning and permitting. Because as long as it takes 10 years to develop transmission lines, we will remain behind schedule. So this part needs to be also improved. And in Europe, European Commission tries to implement new rules to streamline the processes, to accelerate permitting for priority projects. And it's a combination between streamlining processes, but still having a proper consultation with local populations and local authorities that you cannot and that you should not avoid for local acceptability. So this is a balance and we're working on it, but we're not there yet for sure. We have still lots of work.
Melanie.
I'd love to just weigh in on this because I think this idea of the supply chain constraints is something that we saw as a downstream needer of this clean power. Obviously, as I mentioned, 19 gigawatts of renewables under PPAs today already contracted. But because of that experience, we started to see exactly what the panel's talking about, the supply chain constraints. And so earlier this year, Microsoft announced a partnership with Hanwha Q-Cells, which was the first of its kind partnership actually on the solar supply chain side, on the solar manufacturing. So Hanwha Q-Cells, sort of bolstered and accelerated through the Inflation Reduction Act in the United States, opened up a manufacturing facility of solar panels in the state of Georgia in the United States. And we need those solar panels moving to our EPC, basically our developers, to develop the projects that we will then need for our carbon-free sources of power. But exactly to Beatrice's point, knowing that there might be concerns further upstream, Microsoft decided to enter into this partnership with Hanwha Q-Cells on the solar supply chain, going even further upstream to the solar panel itself. And I think it's a really, sort of unique example of, again, where companies can step in and talk about, where the need is and what we can do to help support the growth in that space. There's another piece too, which is, earlier today, Microsoft released a paper on nuclear policy and what is, Microsoft's position around advanced reactors and nuclear energy, both fusion and fission, because again, it's everything, right? For us, we need all carbon-free sources of power moving into these systems, long duration storage and the like, because of some of the constraints we're seeing, throughout the system. And I think this is just another great example of how we get at some of this resilience and supply chain issues.
So Morten talked about supply chain issues. You're kind of the supply chain, as Beatrice said, one of too few suppliers. You might disagree with that assessment, but how are you seeing your ability to deliver what EDF and others need?
No, it is true that we have, there has been, especially first with the semiconductor crisis that we were facing during COVID. Then you're coming out of COVID, and then there has been other challenges, and especially this strong uptick in the electrical investment that is needed. And then you get the super cycle of data centers with machine learning and Gen AI coming as well, which is taking a lot of the capacity as well that would normally go into the power side, which is now going also into the data centers. So this is where the industry is really being stretched on capacity. But we as ABB, we have also made significant investment in more than doubling capacity in many areas, both in, especially in the United States and Mexico, based on the Inflation Reduction Act investments that we know are coming, and the CHIP Act, and the different, and the Job Act. So all of these are kind of, so we are expanding capacity. So that, but we also see that it will be a shortage, not just of equipment, but there will also be the number of engineers, with the number of electricians doing a lot of the work, the practical work of the installation, because you can build a transformer and switchgear and all the equipment, but then it also need to be connected to the grid. And you need to have those smart engineers who can do that also out on site. If they work with ABB, or they can work with EDF or Microsoft and others, but this is where we also need. So that would also be a skill set that we will be short of. So we need also more engineers, more technical personnel to be able to do this transition. So that's another need in the industry. That's why we are pushing a lot also to out with schools, with university, but we try even at the high school level to get people interested in joining the technical, the engineering industry. And hopefully, I mean, they can come to ABB, but just into our industry. We need more talents, because engineering is so important for handling these challenges we face now as a global society.
And I don't know whether the situation is the same in Europe as it is in the United States in terms of what they call the silver tsunami, people who have hair color like mine who are aging out and moving on, and there isn't the pipeline of talent to fill in those gaps. Is that a challenge for you? And Melanie, I see you want to.
Yes, it is the same challenge that we're facing, and it goes even in most countries. Also, I was in China a couple of weeks ago, and even there we have the same challenge. Even there is high unemployment now on the lower grades, but we don't have enough engineering know-how to go into the technical industries. So I joke a bit often that I say we have more than enough influencers, but I would like to have more technical engineers.
That's true in life in general, I think. More than enough influencers. Melanie?
To build on sort of more sort of lived experience and your anecdotal sort of perceptions of where the skilling is. Just yesterday, LinkedIn put out their COP28 like global green skills stock take, and to provide some data behind what you're seeing in the market is that only 1 in 8 people have a green skill. And it's actually in the case of women, it's 9 out of 10 women lack any single green skill. And so there is a shortage in the market of anybody with these green skills and these green talents. But meanwhile, LinkedIn found that the hiring for these roles is outpacing the supply of people with them. So there really is this opportunity. How are we helping to skill the future workforce? Because in addition to the silver tsunami, there is a cadre of people that are coming into the workforce that could fill these roles. It's just how do you get them the skills that are required through whether it's online learning courses or sustainability skilling courses, and how do you use digital technologies to provide a much more democratized access to the tools, especially in the case of digital tools, which obviously your engineers need and others. There's an opportunity to do it to close the gap that seems to be widening around green skills. But it's something that now that we have data behind it, we can now call attention to where those gaps are and what the tools are to do to fill it. I think there's an opportunity to get to address this concern about that widening gap with the silver tsunami.
Well, speaking of data, I want to turn to the topic of digitalization and some of the opportunities and challenges you see there. We've got this, we have the Internet of Things, we have the cloud, we have AI now, which is just ramping up faster than anyone can even imagine. And all of that's going to require a lot of first digitalization, and then we can talk about the security pieces of those as well. Starting with you, Beatrice, how does that fit in, and what are some of the challenges and opportunities that you see around digitalization of the grid?
Well, we have started with the deployment of smart meters, and as I was saying, it was a big game changer because we are now able to collect data from 36 million households in France and have remote control. And during winter, for example, we were able to move by 1 or 2 hours the timing of heaters, water heaters. And it allowed us to erase a peak. So that's thing that you can do in a very practical way that have a big impact, in fact. We need to do more, obviously, to adapt our networks because, as you said, networks are old. And we have to change the way we operate them. It is a challenge in terms of skills, and people need also to be upgraded. So we are dealing with all that, with training of people to new technologies, with investment that we need to put in that, and it represents a lot of required funding, and to be able to have a grid which can so better control the consumption and the way people consume, and offer other services like electric mobility, for example. And I think we are on the right path, but as I was saying, it's an investment over 10 years. So we will be there, but in 10 years.
Christian?
Yeah, so just to give a few data points on how much the system is changing and what that requires, because most, especially distribution grid system operators that I talk to, they are adamant that we can only operate the future grid if it is almost fully automated. But just to understand, how much has the system changed? If we look back maybe 25 years, 30 years in Germany, you would have some couple of hundred power plants powering the entire system. Today, E.ON's grid alone in Germany has 1 million feed-in points. So this is how decentralized the system has become. And on top of that, we need to add all the electrification of end users. By 2030, we expect some 40 million electric cars in Europe. We could add another 50 million heat pumps. So hundreds of millions of devices that need to be powered, that are adding massive loads to the system. And for that to function, we're just dead dependent on a better digital optimization. So that has a sort of software component, a digital component, but it also very much has this infrastructure component, which is that in big parts of Europe, we don't have smart meters. So in order for us to be able to steer the load in a smart way, in order for us to be able to optimize the system, we need that infrastructure in place. And this is also a precondition, by the way, for the market arrangements that we heard about before. Because if you want to go to a 24/7 world where literally every hour of the day is carbon-free or at least measurable, you need to have those measure points in place and in order also to set up the market arrangement to allow for this. Today, we assess the carbon quality of energy on an annual basis with guarantees of origin, and a lot of companies are saying, well, that's not quite enough for us. We need to be able to account for our scope 1 and 2 emissions, and we need to know what we're actually using. So we need also a new generation of market design eventually, but it needs to happen at the right pace because that system will only function once we have the infrastructure.
Yeah, I imagine this is a significant opportunity space, Morten, for ABB.
Yes, it is. And we talked about also the use of artificial intelligence now to drive, especially in the field of energy efficiency. We have a great example with one of our partners called Brainbox AI from Canada, where they do an artificial intelligence algorithm they running on cloud services, where you can transfer all the data from an HVAC unit, so the heating and the cooling units, and in the buildings. You get all that data up on the cloud, but in addition, you're taking in all the, the weather forecast, all other data points that you have there, and also looking at the history. And in that way, you're able to save up to 10% of the energy of the building, the whole building, without jeopardizing or sacrificing the comfort level inside the building. So I think these are examples we'll see as well, that we can scale these examples to, just for buildings is consuming 30% of all electricity around in the world. So you have to make buildings much greener and reducing the footprint and the energy needs of buildings. And as I say, artificial intelligence can help us to do a lot of that. And that, I think the next part will be, how can you use that even in the EDF grid, where you use the same type of algorithms of using also the grid even smarter. But then first, as Christian said, it needs to be digitalized, or else it doesn't work.
I want to switch gears because there's so much more I want to talk about in the not even 10 minutes that we have left. We've been talking more about the developed economies. We haven't looked at the global south here, and places where the grid is both north and south is less reliable, or in some cases non-existent. First off, from ABB, your perspective, Morten, how do you view that space in terms of what's needed, what's possible, and the preconditions that you need to even work in those markets?
Yeah. No, I think the first point is that we, as I said earlier as well, we should go straight into the renewable power generation and don't take that detour that is often being used through carbon emission-based power generation. So I think that will be an important part for when developing countries are developing, that we also, we as ABB, but I think it's also going to getting the right funding in place and for these investments that have to happen, because we know with the population growth where it's going to come, it's Asia and it's Africa. That's where, and we also know that the energy consumption, that's also the places we will see the biggest increase. So when we want to address the carbon emissions, that's also now we have a golden opportunity, if we get this right, to get started in the right way. But it's also a big risk that we can do it in the old-fashioned way and we don't use the new technologies available. And then, that can just not happen this time. So we as ABB, we are also there investing together with our partners, many of these countries, and how we can help getting started, as I say, on the right foot and not have to take that extra step.
Yeah, Melanie, I'm guessing that a lot of these parts of the world are where Microsoft either has or plans to, would like to build data centers. What are some of the challenges and opportunities that you see in setting up shop in developing markets?
Well, one is really understanding, make sure we have the capacity and the understanding of what do they need and where the existing energy systems are. And what we're seeing and what we know is that in many of these countries, they're a coal-based system, and they're relying on coal-fired power plants. And so for a lot of these conversations starts with, well, what are the alternatives to coal-fired power? How do you then bridge that gap from what is the incumbent technology that's been there for several years? It could be subsidized. How do you actually start that transition away? We have a strategic partnership with a company called TerraPraxis, which is using digital technology to help look at the 2,400 coal-fired power plants and how do you transition them to carbon-free sources of power. There's some unique qualities with coal-fired power plants. They're already connected to transmission. They already have that interconnect established. So you get through that one bottleneck, and then it's really about what would you swap it out with? What are the alternative technologies you can do there, which is a good first step to thinking that through. You also see the work that's happening in these government partnerships that are looking at development banks along with country governments trying to accelerate not only the coal transition in these countries, but also build in and invest in the clean power projects around in these key markets, which then to your question about where we go and how we partner, they become more attractive countries and places for us to go because you have the opportunity to actually source carbon-free sources of power to meet our energy needs.
All of these topics are ones we can just keep going on, but Beatrice.
Yes, just on that part, we are active at EDF in around 30 countries, in Africa, in the Middle East, in Asia, in America. And what we see that there is no one size fits all,
Of course.
And many countries are developing intensively renewables, wind and solar, and have to face these intermittency issues. And what kind of baseload can you develop in parallel? It depends. In France, we have made the choice of nuclear, so we are investing heavily in all low-carbon sources, nuclear, wind, solar, hydro. In some other countries where there is no nuclear, gas can ensure the transition. I cry each time I hear a new coal investment in China. I think it's a nightmare. But you need also to face the fact that in some countries, like Uzbekistan or the Middle East, if you want to have more renewables rapidly, how do you enable this change? And we are working on some gas projects, for example, in Saudi Arabia, together with CCS, with carbon capture. And I think these kind of countries, they have the right resources to develop these new technologies. So that's where I was saying we need to deploy all solutions that we can. We need all of them. In Africa, we are building lots of hydroelectricity projects because they have so much resources in hydro. So you have always to optimize according, of course, to the local resources, to the frame, to the regulatory frame, because to do nuclear, for example, you need quite a heavy safety and regulatory authority in place, and it's not adapted to smaller countries. So each time we have to adapt and to find the best solution to have low carbon solutions. But, you know, there are sometimes debates saying, okay, we should do only solar and wind. Yes, but if they don't have baseload, they cannot take it. It just doesn't work. So how do you do it? And what are the best options? With an open-minded mind, I would say, with an open-minded spirit to be better. And just to mention that, to decarbonize, there are, you know, other solutions that are being looked at, and I'm impressed by the Middle East initiatives in that regard. For example, we are, with ABB, we are about to deploy an offshore HVDC network to decarbonize the oil production of ADNOC.
Wow.
So you can think it's a bit weird. What is green oil, you know? But it is part of the solution. Because if we say we still need oil for some years, it's better to produce oil without CO2 emissions. So, and I'm impressed by the strong willingness of ADNOC, because it has a cost, and they want the grid to feed the offshore activities, and the grid and the onshore grid becomes greener and greener. So that's also part of the solution.
Wow, yeah. Christian, want to weigh in on this?
I know it's fine. So when you talk about transition, right? Obviously, one size doesn't fit all. So when you look at developing economies versus developed, don't you think there should be more resources should be provided for them to transition efficiently? Because I'm working with some of the project developers in Africa right now, and I see that the biggest issue is right now on funding. You know, like when I was speaking to some
Yeah.
some bilateral agreements. It's easy to talk to mention, you know, we need to transition, we have to get there. But in reality check is, you know, the funding gap is still huge out there. I mean, do you think the reality check should be taken into account before you talk about, you know, transition? Same thing like countries like India, where there have been generations relying on the coal, right? I mean, it's hard to grow up in 1-2 years. I mean, to transition quickly. How do you see that? I mean,
So,
transition is not going to happen. And I have a question.
we're almost out of time here, so we talked a little bit about the funding and who wants to take on the question of funding in the developing world?
Funding, yes. What we see in Africa, if I take your example, is that we manage to mobilize funding from multilateral agencies, from the World Bank, from JBIC, credit export agencies.
Excuse me.
Just to answer that.
Yeah.
So I'm not saying it's enough. I'm just saying that it's a hard and very long and very intense work to manage to have all these heavy people, but very useful people doing this project together, but it makes this project feasible. We're going to invest in Malawi in a 350 megawatt dam. Malawi is a very small country. We would not be able to do that without the World Bank guarantees. So there are systems, we need to do more, and obviously countries need to invest more through World Banks or other agencies, but these tools exist. They can be improved, but they do work.
Yeah. We need to wrap up here. I'm committed to an on-time arrival of this vehicle, so I
Fly
want.
more planes with you.
Yeah. I want to ask each of you a question in roughly a minute or so for each of you. When we meet back at COP30 in 2 years, Belém, Brazil, how do you hope that this conversation will have changed? And from each of your vantage point, what do you hope that we'll be talking about then that maybe we'll have already worked through? How will the conversation have changed for you, Beatrice?
That's a tough question. That's a tough question. Well, compared to today, I hope, of course, that we will make progress every year in our commitments and progresses. But I would say on the supply chain side, which is really the tricky part today, not only for transmission or for all components, for raw materials, for everything, it's becoming the bottlenecks of energy transition. So I hope that in 3 years, compared to now, we will be more optimistic in that point of view, from that point of view.
Yeah.
I would say the increased focus in these negotiations on real drivers of emission reductions, renewable deployment, energy efficiency, other low carbon technology deployment, I think is very, very helpful. And some of the, let's say, political innovations we've seen in Europe in the last few years is that we have now effectively focused on how to unlock, for instance, the permitting challenge. So we're now looking at an overriding public interest principle in Europe to be deployed and seen also unfolded in court cases to say delivering on climate action is an overriding public objective or priority, and therefore other things that might stand in its way can let's say can be assigned less weight. We're also looking at acceleration zones for renewables, and it's a bit the philosophy that Beatrice was talking about. Let's build the grid connections before, as soon as we have that zone, so we don't wait another 10 years once the turbines are up. So very concrete and tangible ways of accelerating the pace of deployment and the deployment of different types of solutions will be very welcome. And I hope the conversation has shifted towards that much more actionable, let's say, mode.
Yeah, I'm going to skip over you and give you the last word. So, Melanie.
I'd say that I think in 2 years' time, two things will be hopefully true. One is the amount of conversation we've had already in the last year on transmission in terms of its breadth. Obviously everyone, people have been aware of the transmission bottlenecks that have existed, but they're often those that are dealing with it every day. The fact that there's a grid action plan out of Europe, the United States just passed some more policy around transmission at the federal level. It just feels like in the last year, the heightened breadth of people talking about the transmission challenge is significant. And it's a box we have unlocked and be able to see the challenges there that I am hopeful that in the next 2 years, there's gonna be real progress made there. The reason why I'm hopeful for that is because we're also at just the very beginning of how you apply advanced AI to various parts of our energy system to help accelerate progress there. We don't know necessarily what's going to come of this, right, to date, because we're still at the beginning of it. But I think there's an opportunity here that potentially you can bring some of these timelines in on various technology developments, battery storage technologies, renewable deployments because of this. So I'm hopeful in the next 2 years' time, if you look at just what happened in the last year, it feels like in 2 years' time we'll be in a much we'll be able to show more progress towards these goals.
And one of the big unknowns is, will AI exacerbate some of the problems or solve these challenges as well? Morten, as I said, you get the last word.
Well, thank you. And for me, I would be very practical about my wish list would be that all our suppliers and customers have set themselves their net zero ambition, hopefully already by 2030, that they have identified where they use and where they waste energy, and they have a clear plan, an action plan to implement it within the next years. If it could be there in 2 years, I would be happy, and I hope if everybody becomes carbon neutral or having a plan of net zero, then we are taking some major steps. Yes, governments need to help, regulations need to help, but in the end, it's a lot down to every company and corporation or small and medium-sized companies as well, to set those targets and to be able to get there. If we can get that commitment across the globe, then we would be a very good place in 2 years' time.
So much to do, so little time. I'm not sure we solved the problem today, but we certainly illuminated the myriad challenges and some of the nuances within those challenges of what needs to happen in not just the next 2 years, but for the next 20 or 30 or more. So with that, I want to bring this to a close. First of all, thanking ICC for our host, and ABB as our sponsor, and thanking Melanie, Morten, Christian, and Beatrice for participating, and for all of you both in the room and online being part of this today. Thank you all so much.